Now let's talk about solving quadratic equations using graph or graphical solutions to quadratic equations. Before that, let's start with our general quadratic equation. That is ax squared plus bx plus c. What I'm going to do, y is equal to, since we're going to sketch a graph and we need two axes at least. So the curve or graph of a quadratic equation is called a parabola, and that's how parabola looks like. So that this shape or this shape. So these are the curves of, or that's how the curve of a quadratic equation looks like. So all the time whenever we sketch a quadratic equation, the curve is going to look like this: curve number 1 or curve number 2. Right? Sometimes the domain can be restricted in such a way that you may not see the first half, you may just see a portion of it from here downwards going, and not necessarily everything. But then without any restriction, this is how the curves are supposed to look like. But then what's the difference? At what point do we have curve number 1, an N-shaped parabola, and at what point do you have a U-shaped parabola? It depends on the value of a over here, that's the leading coefficient. If the coefficient of x squared in the quadratic equation whose curve we are sketching is less than 0 or is negative, that's if a is negative, then you're going to have this curve, and we call it maximum curve. I believe you know why it is called maximum curve, because it begins from a low point, rises, and then attains a maximum and then continues to fall, right, unboundedly. So we believe that this is not the lowest point, as it can keep going, but this is a maximum point because it rises up to this point and then it begins to fall. So it's a maximum curve. You can always find the maximum of that curve, but it's difficult to find the minimum, right? Unless we are given a certain restriction on the domain. And then next, when the coefficient of x squared, which is a, is positive, that's greater than 0, then the curve is going to look like this, and we call that a minimum curve. So minimum because it starts from somewhere up, keeps falling or reducing until it attains a certain minimum, the lowest point, and then begins to rise again unboundedly. Right? So that is how it looks like when the coefficient of a is positive. Right? So given a quadratic equation, you can always tell the nature of that curve, whether it's going to be a minimum curve or a maximum curve, whether it's going to be to increase and attain a maximum and then reduce, or going to bow up. It all depends on the value of a. Next is this point, the point where they turn. Right? We call it the vertex or the turning point. So this point is called the vertex of this minimum curve, and this is called the vertex or the turning point of this curve. So a vertex is, for a quadratic equation, it's either a minimum point or a maximum point, depending once again on the value of a. If a is negative, then you're going to have a maximum curve, so the vertex is a maximum point. If a is positive, then we're going to have a minimum curve, so the vertex is a minimum point. Since it's a minimum point, or since it's a point, we can find the coordinates of that point, the x value and then the y value at the turning point or at the vertex. So the x value at the turning point is given by x equal to negative b over 2a. It means that you just need to identify your a and b from the quadratic equation given, and then find the value of negative b over 2a, and that gives you the x coordinates at the vertex. After finding the x coordinate, you substitute that value into the quadratic equation given, and then you get the y coordinates. When you do that, you're going to get the y coordinate to be y is equal to 4ac minus b squared all over 4a. It means that the vertex of or the turning point, which is either minimum or maximum, so whether minimum or maximum point, so goes with the same formula, right? So the vertex is given by negative b over 2a, and then 4ac minus b squared over 4a. You are not expected to memorize both formulas. What you're expected to do is that you should be able to find at least one of them, either the coordinates or the x coordinates, because after finding the x coordinate, you can just substitute into the equation to get the y coordinates, or the other way around is also possible. So that is how you find the vertex or the turning point of a curve, which is quadratic. Now, the next thing we're going to talk about for quadratic curves is the line of symmetry. And I believe you know what a line of symmetry is. One that divides the curve into two equal parts so that each half looks like the reflection or the image of the other. Forgive me for my lines that are not straight. It's supposed to be a very straight line. So a line through the vertex is what we call the line of symmetry, because the vertex is the exact middle of it's at the exact middle of the curve. So line of symmetry will be the line that divides the curve into two equal halves. And since the line of symmetry goes through the minimum or the maximum point or the vertex, let me do a simple sketch here. I have a curve here, and let's say this is my curve, y is equal to a squared plus bs plus c, and there's a minimum point. The line of symmetry goes through this point like this, and then it goes. So it means that, and it goes through the y-axis, so a certain x value, and next x value is the x coordinates at the vertex. It means that the equation of the line of symmetry is given by x equal to negative b over 2a, and that is how you find the line of symmetry. Well, remember, the line of symmetry is a line, a x equal to negative b over 2a. It is a line and not a value or a point. So whenever you are asked to find a line of symmetry, you're expected to produce an equation that starts with x equal to a certain number and not just a certain one value or a point. It's the same formula we use for the vertex, but then over here, this is the x coordinates at the turning point. This is a equation of a line, and that's how you find a line of symmetry for a quadratic curve. Now let's try some example. Let me use a different color. Okay, so for 3x squared minus 12x minus 1 is equal to 0 or equal to y. So y is equal to this. And we need to find the line of symmetry and then the turning point. So for the vertex, or for line of symmetry, we know x equal to negative b over 2a. Our b is 12, so negative 12 is going to be negative negative 12, which is positive 12 over 2a. 2 times 6, 2 times 3, sorry, that gives us 6. So 12 over 6 is 2. It means that our line of symmetry is x equal to 2. And then our vertex, which is going to be a point, so we need to find the y coordinates of the turning point. So we substitute this value into the equation to get the y coordinates. We're going to get, for x equal to 2, y is equal to 3 times 4, that's 2 squared, minus 12 times 2 minus 1. And that is supposed to give us 12 here, 12 negative 13. That means our vertex or our turning point is 2, negative 13. And that is our turning point. So a rough sketch of the curve is going to look like this. So first of all, let's also identify whether this curve is a minimum curve or maximum curve. Because the coefficient of s squared, which is 3, is positive, it's going to be a minimum curve. And we know a minimum curve is a U-shaped curve, like this. So that's what we're going to draw. And we know the line of symmetry is 2, negative 13. So, okay, so I think I should have drawn my curve somewhere, my x-axis somewhere up. So 2 here, negative 13 somewhere here. And this is a line of symmetry. Mostly it is drawn with broken lines. X equal to 2. And there's a turning point. Later we'll talk more about, we could have also found the root of the equation and then we plot them over here. So that's how roughly the sketch is going to look like for this particular equation. Let's go back to this question, the same question, and I explain something small. Y is equal to, once again for the question, y is equal to 3x squared minus 12x minus 1. I'm going to equate the question to 0. So I'm going to take this out and make it equal to 0. That means y is equal to 0. Which also means graphically, equating it to 0 means you are finding where the curve intersects the x-axis. Because y equal to 0 is the same as the x-axis. Now let's try solving this. Let's complete the square of this equation. So completing the square, I think it's a question you've done already. So let's factor out the 3. If you've not yet watched the completing the square, you search for it from the videos and then you learn for that one. So 3x squared minus 12 over 3 is 4x, then minus 1 equal to 0. Then let's complete the square of the one in brackets. So 3 out, half of negative 4 is negative 2, so minus 2 all squared, and then minus 2 squared minus 1. 3 out, x minus 2 all squared. Then this is 4 times 3 is negative 12 minus 1 is going to be negative 13. So this is how it looks like after completing the square. Now what is interesting over here is that for every quadratic equation, after completing the square, the value here, right? So after completing the square, the quadratic equation is going to look like a x plus b plus c squared. The value here, or plus c, okay, the value c is a maximum or minimum value of the curve depending on whether the curve is a minimum or a maximum curve. So over here, the negative 13 is the minimum point, a minimum value of the curve, right? The y components or y coordinates of the vertex is called the minimum or the maximum value of the curve depending on the nature of the curve as well. So the negative 13 is a maximum value. Sorry, minimum because it's minimum curve. So minimum value is equal to negative 13. And then the x coordinates at the minimum is the one in the brackets after equating it to 0. So the same as a line of symmetry. So x minus 2 equate to 0, x equal to 2. So this is a line of symmetry. X equals to 2 is a line of symmetry, and then 2 is the value of x at the vertex. It means our vertex is 2, negative 13. So you realize it's also easy after completing the square of the quadratic equation, easy to find the maximum or the minimum value, and then the x coordinate as well as the line of symmetry. So our vertex is 2, negative 13, which the same thing we had over here, 2, negative 13. So it makes it easier trying to figure them out using the completed square form of the quadratic equation. And if the equation were a function, right? Let me type in this. Or better still, the range of this equation, right? The range of this quadratic equation or this curve is that y, or if it's f of x, we would have written f of x. Y, since this is the minimum, it's a minimum curve, this is the minimum value on the curve. So it's going to be y is greater than or equal to negative 13. If the curve were maximum, we would have written y is less than or equal to negative 13 as our range. So once again, after expressing ax squared plus bx plus c equal to 0 in the form, let me use different variables, p x plus q all squared, oh I omitted the square here, plus r in this form. The value here is a maximum value and also helps us to find the range of the curve. So that if it is a minimum curve, then it means the lowest value is r. So our range is going to be y is greater than or equal to r. If it's a maximum curve, it means the maximum value the curve will ever attain is r. So this for minimum, and for maximum is going to be, the range is going to be y is less than or equal to r for maximum. So this is the information we need to know about the quadratic curve, and then it's going to help us to sketch a lot of quadratic curves. So let's start with some few examples. Let's start from this question. Complete the table of values for y equals x squared minus 4. So this is a quadratic, and very easy here. We just need to substitute the values whose y components or values are missing. So first we do, when x is equal to negative 3, substitute into this equation to find your y value. So for the first part, I'm doing only one of them. Y is equal to, when x is equal to negative 3, y is equal to negative 3 squared. Make sure you are squaring everything in brackets. Minus 4. That's going to be 9 minus 4, which is 5. So over here we have 5. Do the same thing for this. When x is 0, y is negative 4. When x is 3, y is still 5. And that is all for the missing values. Next, we plot the values. So negative 4, 12, 3, 5, 2, negative 2, 0, negative 1, 3, 0, negative 4, and then through to the end. So let's plot that over here. The first point is negative 4, 12. So negative 4 is here at this point, and then 12 is up here. So we plot that over here. Let me use a different color. Okay. So negative 4, 12 is here. You can use a dot. Next is negative 3 and 5. Negative 3 and 5. That should be here. So negative 3 on the x-axis, 5 on the y-axis. Next is negative 2, 0. So negative 2 on the x-axis, 0 on the y-axis, that is here. The next is negative 1, negative 3. I have the values written, so I'm just reading from that. Negative 1, negative 3 over here. 0 -4. So 0 on the x, -4 on y. That occurs here. 1, -3. 1 on x, -3 on y is here. 2, 0. 2 on x, 0 on y is here. 3, 5 here. And finally 4, 12, which goes up over there as high as the first point. Now next is to just join your point with a freehand. It shouldn't be a straight line or any ruler. So let's do that. Pardon me if my curves are not straight because it's freehand. For the first part, oh no, this one is nice. So let's go. Come on, I've done well. That's okay. So that's a rough sketch of our curve. And here, let's try and do some things over here. So if we were to find the line of symmetry, right, for this curve, a line of symmetry, our b is 0 because there's no term, any number multiplying x over here, and then our a is 1. So our line of symmetry is going to be x equal to -0 over 2 times 1, and that x equal to 0. X equal to 0 is the same as the y-axis. So you see that the y-axis divides the curve into two equal parts. So that's it. And then the root of this equation, if you were to find the root of this equation, it means you have to equate everything to 0. Right? You have to equate y to 0. And so you equate everything to 0. Equating y to 0 means the x-axis. So root of the equation on the curve is where the curve intersects the x-axis. That's where y is equal to 0. So you can even find it from a table. From the table where the curve is, where the y values are 0, here and here, and at those points x is equal to 2 and a -2. And we see that here where the curve meets the x-axis at x equal to -2, x equal to +2, means that if we were to solve this equation, we would have had x equal to -2 or x equal to 2 for this question. Now next question for this, complete the table of values for y equals 2x² plus x. So same thing, fill your values, and I'm going to write down the final values here, hoping that you take your time and get it right. We have for 3 we have 21, for 4 we have 36, and then for 5 we have 55. Then we plot them. So for the first point is 0, 0, 0 for x, 0 for y. Next is 1, 3, 1 here. So you may count the lines over here, you realize there are 10. So each line is 1 unit. So 1, 3 is somewhere. Let me zoom in. 1, 3 is somewhere here. 1, 2, 3. Then next is 2, 10. 2 here and 10 here. Next one is 3, 21. 3 here, 21 here. The next one is 4, 36. 4 and 36. So 4 here and 36 is just here. Then 555, which is high point. Okay. Then we join with a freehand. Remember, no ruler in this case, but then it should be as accurate as possible. So we join. Forgive my lines that are not as straight as yours. So let's draw. You go here, goes through the point. You must pass through each point. So yeah, remember from the beginning of the video I told you the curve of a quadratic equation, and for that matter this one is supposed to be either a U shape or an N shape like this. But when the domain is restricted, then you may have just half of it, and this is a clear example. Instead of allowing us to plus -5, they said we should plus from 0 to 5. So we cut off any other thing that is less than 0, and that's the reason why the curve is not a full curve but then a half curve. And the B part says that use your graph to solve the equation 2x squared plus x is equal to 30. So the 2x squared plus x is the curve we've sketched, right? So use your graph to solve this equation within this interval from 0 to 5. What is the solution to this equation? Right? The 2x squared plus x what we've already sketched with over here. And now equal to 30 means that you're going to draw a straight line, straight horizontal line through the y-axis through 30 and find out where through over here. This is 30. And then pick where the two curves meet. So we may zoom in and check where they meet. So they meet somewhere in between over here. Or better so trace 30 until you meet the curve, and then you reduce it down. Maybe I may not be able to get an accurate value, but that's where they meet, and then you trace it down and come down here to reach the value over here. In fact, the actual value is supposed to be somewhere 3.6, but then for the sake of my crooked lines, I'm having 3.9, which is not too good a solution because it has to be at least very close. But at least this is the idea behind this, right? Because of the lines that are not straight, it should have been somewhere 3.6, but I'm having 3.9, no, 0.3 different, which is a bit far. But this idea, this curve has been sketched already, and what we need is 30. So you trace from 30, draw a straight line until you meet the curve, and then trace it down and read the x coordinate of that point. And that is how we solve this. There's no other question. And here's another example. On the grid, draw the graph of y equals this then given. So over here, unfortunately, we're not given any table. It means that we are supposed to use our own table if only we want to. Other than that, you can just, this is the domain, right? -2. If you want to do a table, you start from -2, -1, 0, 1, until you get to 6. Then you fill in the y value. So this for the x value is y value. So put when x equal to -2, when x equal to -1, and find all the y values. And then when you are done, you plot it. Right? But then I'm going to do that straight ahead without drawing any table. So when x is equal to -2, what's our equation? Y is equal to 8. So you have -2, 8. -2 on the x-axis, +8 on the y-axis. So that has to be somewhere here. When x is -1, y is 1. So -1, 1 is here. When x is 0, y is -4. 0 on x-axis, -4 on y-axis. When x is 1, y is -7. So 1 here, -7 comes down here. When x is 2, y is -8. 2, -8 is here. Then when x is 3, y is -7. So the values repeat and they begin to rise. So then we have 2, -8, and next is 3, -7 over here. Then 4, negative 4 here. Next is 5, 1. And we can guess the last point, 6, 8. Now we draw the graph by joining them with a freehand sketch. And once again, you should be as accurate as possible. Not as you can, but as possible. Okay, then the next part, it goes from here through to the point, and it goes. Yes, you always have to forgive me for my lines that are not straight. So our curve is, and sometimes you just need to write the equation. Y is equal to x squared minus 4x minus 4 over here. So that's our solution. The next is write down the line of symmetry of the graph, and that is here. You look at the curve and you see that the line that divides the curve into equal parts is lying through this. Is a different color. There's a line over here, and that line is the line x is equal to 2. So that is x is equal to 2. Once again, if you write only 2, that's wrong, because the line of symmetry is a line and it must come with equation and not just a number. If you doubt, you can calculate it, right? Our b is negative 4, our a is equal to 1. So x equal to negative b, that's going to be 4 over 2a, and that's going to x equal to 2. Right? And next point is that next question is use a graph use the graph to solve the equation this equal to 0, right? So equal to 0 means y is equal to 0. So you have to find where the curve meets the x-axis. Y equal to 0 is the same as x-axis. So solving this equal to 0, if it were equal to a certain number, we would have drawn a line through y equal to that number. Here it is equal to 0. So you draw a line through y is equal to 0, which is the same as the x-axis. So what we need is where the curve cuts the or intersect the x-axis. We're going to read that and find what our solutions are. So first, it is passing through, or I think I turned this somewhere here. Okay. So first it passes through this point and then it goes through this point. So the values you're supposed to get are x equal to, the point here, I think it should have gone somewhere here, is negative 0.8, somewhere that area. So it's supposed to be negative 0.8, and then the point here is between 4.8 and 5. So maybe 4.85 or 4.82, 4.83, any of those values. Okay. So negative 0.8 and then positive 4.8 something. So that something will be okay. So first is negative 0.8, and then next is 4.8, let's say 4.83, and that is enough. And finally, last example over here. Complete the table of values for y equals this, which I believe you can easily do it. So you fill in the two missing values. 4 you get 0, and then for 6 you get negative 12. Then you start to plot all of them. So take your time and then plot all of them. Let's start. Negative 1, 5. I'm going to plot all of them and then we'll continue from there. So I've plotted everything here, and our next thing is to join them with a line or the continuous line. So you start from here and you draw. So I would like to start from up here and draw downwards. No, this looks bad. Then the other part goes here. And there's another point down, so it goes, and that's our curve. This is a maximum curve. As you can see, the curve is negative x squared plus 4x. So it's a maximum curve because the coefficient of x squared is negative. So it has to be an N shape or a dome shape. Now the B part says that use your graph to solve the equation 4x minus x squared is equal to 1. So the left side has been sketched. Now what we need to do is to sketch the right hand side, or better still, we trace y equal to 1 until we meet the curve. We are going to do that with a different color. So for y is equal to 1, where does y equal to 1 meet the curve? So that's it, y is equal to 1 is here. Then it goes through, and this is where they meet the curve. We trace them down and then we try to measure somewhere here. Somewhere here, another one somewhere here. Right, so I'm having supposed to have somewhere 0.2 something. So since I'm somewhere in the middle, I would like to use 0.25. The answer is 0.27. Somewhere close, so that's fine. 0.27, and then the other one 3.7, more than 3.7, so 3.73. So answers are 0.27 or 25, which is also right. We have 0.27 or 3.73. Right, and these are the solutions.